talk about. So we talked about distance formula. We talked about writing equations. We have two more things I want us to talk about. Partitioning a line segment and a little bit of proofs, because it was requested that we talk about proofs earlier today. So we've got I took a picture here, and I took this picture because I wanted to point out to you that when you are in a lesson in Edgenuity, if they're going over vocabulary, there's a plus sign in the top corner. If you touch the plus sign, it'll become a minus sign like you see in this image. And you can tap glossary, and then you can have your definitions of your words. You can tap and highlight these, and you can copy and paste them into the eNote, and that will help you to have them later to like refer to. But I just wanted to make sure everybody was aware that this is here, that it does have definitions for the vocabulary terms that they are teaching you. And you can also go to this and type in a word into this spot, and it will search up words that aren't even math words. So like if there's a word that you just don't know what it is, you can go to this glossary, type it in, and it will tell you the definition. So I wanted to make sure that you were aware that that was there. We're going to talk about, they talked about ratios for line segments. Like here, you could take these segments and write the ratio for them. And that is just a reduced fraction representing the pieces of their lengths. But the main thing I want to talk about is this formula, because the first time I saw this formula, I was so confused. So I wanted us to have some time today to talk about that, because this is on the agenda for today. So if you are partitioning a line segment, you, in the ones we just looked at with the number line back here, you only have X values. But if you have them on a graph like this one, you have X values and Y values. So you're going to be wanting to think about, let me move ahead. I took a lot of screenshots of their work. Here is having an X and a Y coordinate. So I'm going to demonstrate with one that we are finding an X and a Y, because if you can do the ones with the X and the Y, you can totally do the ones where you only have X's. But what this does is it's a formula to pretty much find out how much of a slope step you are doing between the 2 points on the graph. So the first part of the equation is like a fraction, and that is the portion of the line that you wish to go. And the other part is just how far apart are your X's, and then the X1 is kind of taking you back because you want to find a starting point. So if I was going to use this formula, I'm going to go to a question that has us use it, which is like, here's an example. And there's two types of questions that they have. There are questions where they give you a ratio, like this, 4:1. And there are questions, let me find another one. That's like a whole lot of pictures of work. There are questions that give you this situation, 3/4 the length. These are two different kinds of questions, and I want to make sure that I point out the difference in this WebEx session, because when I was watching on Edgenuity and they got to this problem, they weren't like, it wasn't super clear that this is a different type of thing. So I'm going to do two problems right now. There's a lot of slides, but that's just because I took a picture of every step they were doing. So we're going to do this example just all in this slide. And I'm going to be finding the X and the Y coordinate. We're going to find the point that divides the directed line segment ST into a ratio of 4:1. So with this, the first letter in the name is going to be the one we're using, unless they use the term, like after they said the ratio, they would say from a point, and then they would give you a point. If they do that, if they say from point something, then that is your X1 that you need to use in your formula. Since they did not say that here, we are going to use S as our first point and T as our second point. So this is our X1 and our Y1 where S is located, and where T is located is our X2, Y2. And for the A and the B, those come from the ratio. In the ratio is A to B. So the A value is 4 and the B value is 1. And so we have our numbers that are going to be plugged into the formula. So again, have your formula on a Post-it or something, have it handy, you're gonna need it. I like here how it's just on the paper for me. That helps me a lot. So the A value is 4, so I'm gonna plug in 4 over A plus B, so 4 plus 1. Next, we have parentheses. It's a product of these things. X2 is 2 minus X1 is -8. And then we say plus X1, which is again -8. So you fill in the formula and then you simplify it. And that's really all there is to it, but it's like a big crazy formula. So you just have to be like, remain calm, find the pieces that you need, plug them in carefully. The fraction out front is going to reduce to 4/5. Then 2 minus a -8 is 10. And then plus a -8 is just -8. So we're doing 4/5 times 10 minus 8. Well, 4/5 times 10 is 8. And 8 minus 8 is 0. So the X value is 0. Now for the Y. There we go. To get the Y value, again, the A and the B, that part's the same. But now we're using Y's. So we're going to say Y2, which is 5, minus Y1, which is -4. Then we're going to say plus Y1, -4. And we're going to simplify that. So 4 over 4 plus 1 is 4/5. Minus a minus is something, that's going to be a 9. Then -4 because plus a negative is subtraction. 4 times 9, 36. 36/5 minus 4. So I need to have common denominators. So 36/5 minus, that's going to be 20/5. And this is going to give me a 16/5. And so the point that we want for the solution is that this is going to be at the point 0, 16/5, or this can be written as 0, and that would be 3.2. And that would be the coordinate for P, which is the point that is dividing it into a ratio of 4:1. So let's see, 0, 3.2, right about there. So that this part is like the 4 and that part is the 1, or our ratio. So again, this one gave me a ratio. That's how I knew the A and the B. And this other version that I wanted to talk about, it doesn't give you a ratio, it gives you a fraction. And this fraction is equal to your A or A plus B. So you're not having to do what's A and what's B. You just know that that fraction is the first part of the equation. So you have, that's the front part. And then if we are finding our X value in this question, they did say from B. When they say from B, that means that B must be your X1, Y1. So you want to be really careful of, if they say from a certain point, that's the first point. And so that means that A is going to be our X2, Y2. And the A and the B, we don't necessarily know them. Well, we can. A is 3 and B is 1. And that's how A plus B is going to give you that 4 at the bottom. But what they did here is they gave you a 3/4 measurement. And how that 3/4 measurement, like pretend you have a line segment and you break it into fourths. If you have 3/4, then you have 3/4 of it, right? And this means that your ratio is 3:1. And that is what 3/4 of a segment is representative of. So that is how you have that 3:1 ratio, which also is the same as if I said 3/4 of the way. So we're going to go 3/4 of the way, and I'm going to start with finding my x's. So I'm going to look at my equation over here. Got x2 minus x1. So x2 minus x1. And then we add x1. And then we simplify. So 3/4, -9, plus 5. That'll be -27/4. So that's -27/4 plus 20/4. So -7/4, which is 1 3/4. So they might want it as a fraction or as a decimal. I've seen a lot of decimal values in the quizzes and stuff lately. If we are finding the y, we do 3/4. We do the y2, 2 minus the y1, and then plus the y1. And so minus and minus is adding, 3/4, 6 minus 4. It's going to be 18/4 minus 4. And so 18/4 minus 16/4 is 2/4 or 1/2. So that's going to be the y value.
Okay, so wait, hold on. I'll tell you where I am at.
I don't know who that was. I don't think that was a question though. Okay, so we have our x and our y value. 1.75 is the x, and then 0.5 is the y. Okay. So that was everything except for a tiny bit of proofs that was requested earlier, which I will go over, but I know I'm already 5 minutes over time. So if you want to look at a proof with me, you can stay on. If you don't want to see a proof with me, then before we go, I would love to see a number between 1 and 5 for the stuff that we've been learning recently. How are you feeling? Are you feeling, not great? 1, are you feeling great about it? 5, where are we at? Looking good. 4s, 4.5s, 3s, 4s. Awesome. 3.5s. Remember, tomorrow, even though we don't have WebEx, I am available for tutorials throughout the day. If a lot of people are wanting tutorials, I might just go into our class room and start a meeting and just let you ask questions that way if it's a lot of people. But I know we have our test coming up, so some of you might have some last minute questions. So if you don't have any questions, then you are free to go. And if you want to stand to look at a proof together, we can do that. I'm going to get a proof ready for if anybody wanted to stay for that. Add a page. There we go. All right. So let me share my screen again. Okay.